Lesson 1, we're going to start with transformations, understanding rigid motion. So if I took this, let me see if I can find something smaller. Okay, if I took this, okay, this is just a sticky note, and I wanted to, quote unquote, transform it, I would literally just move it from its original spot. Okay, so let's name these corners A, B, C, and D. Okay, so on my quadrilateral right there, I'm just going to move it over however far I want to, and then it's going to be transformed that far. Now you just draw a picture similar. You don't have to be like as beautiful as mine. As you can tell, it's such an artwork. So the original is just named A, B, C, D. When I rename the second one, notice that I will change the names of the sides by adding a mark right here. I will say A prime, B prime, C prime, D prime, which just means that when I moved it, this is a copy. Okay, this is just the first move, so I put one mark. First move, first copy. Okay, so a transformation involves moving all of the points to make a geometric figure according to the same rule. So meaning same shape, same size. The original figure is called a pre-image. So original, so write in the original, the word original. And this is the pre-image. And the transformation figure is called the image. So transformations that change the position of a figure without changing its shape or size are called rigid motions. So we're going to write down that word and its definition. Rigid motions. Rigid motions are a transformation without change to shape or size. So, rigid motions is a transformation without change to shape or size. With \O is without. If you don't know that, just write out the word. Next to the word transformation, let's write this in here. It's actually, it's a type of transformation. It's a translation, and that's probably the word you've heard before. And that's more along the language that I'm going to use is translation. Okay, so translation is what we're really doing here. Okay, any questions thus far? I need to go back up, slow down, anything? Okay, so pretty much we've just gone over a definition. So most of these you should know, so I'm going to try to power through them as fast as we can, that way we don't waste any time. If you have your, everybody look at me, if you have your iPad sideways like so, chances are you're going to have to slide up and down. Now if you try to slide up and down, you'll notice that it doesn't do anything. You have to touch the side, either the blue or the white, depending on how much you're zoomed in or zoomed out of your screen. Okay, so if you're going to do it like that, that's fine, but you're going to have to scroll on the side. So don't touch the actual image itself, because then nothing will happen. You'll just try to change the page on you. The easiest way is to go ahead and turn it up sideways like so. Okay, you don't really need your keyboard here, so if you have one like Bailey's, you can turn that thing 360 or 180. I mean, Bailey, you can turn that thing 180. So turn your screen. There you go. And then fold it back down on itself. And if you want to look at it like a book, keep going, sir. 180, it's a half circle. And then lay it back down. And you can lay it down on top of itself like that, and it's more like a book. If you want to sit it up, you can. You just open it up a little bit and it'll stare at you. Okay? It's just however you want to do it. Do whatever's comfortable to you, but don't get mad at it because it's not moving. You have to touch the side. All right, next one. Let's just draw a figure, okay? My figure is going to be a half heart because it's cute. Okay, so I'm going to draw my half heart with labels A and B. Then I'll show you a reflection. Everybody should know what a reflection is. So here's my axis of symmetry, or my line of reflection, whatever you want to call it. But basically, when I reflect it, I'm going to be equal distance away from that line because the reflection is that. And then I'm going to have to draw my half heart. Ooh, this is going to be bad, I know it. Not near as bad as I thought it was going to. Now it looks a lot more like elephant ears than a half heart. But my original is going to be A. My image is going to be A prime. And B prime. Okay? Now if I reflected this again, if I had another reflection, then I would have to look again, have the same distance. Yes. Okay, and then this image will be completely backwards of the first one. I'm pretty impressed with my drawing right here. Now, when I name this, this is going to be A prime prime and B prime prime, or better known as A double prime, B double prime. Okay. So if you copy it or reflect it or move it more than once, you just start naming it by its little tick marks up there by the letter. Okay? Questions about it?
No, sir.
Awesome. The way you can double check these is literally just fold your paper in half. That'll work. Okay, next one, we're talking about rotations. These are a lot harder for me to draw, I will forewarn you. So on this one you might write reflection. This is just a type of transformation. The next one's going to be a rotation. I'm not going to lie, I really struggle with these, so bear with me. What helps me with these is a compass. So I'm going to use a compass to draw mine, because I'm a really bad artiste. If I start with an image, let's just say a triangle. I'm going to go obtuse triangle. Okay? Typically, it will move about a center of rotation, which is sometimes a vertex and is sometimes not a vertex. So if they stick you, and a lot of times, especially on testing, they'll say that your rotation or your center of rotation is going to be your origin. So if my center of rotation is right here, I'm just going to write it in, center of rotation. So if that's my center of rotation, if I was doing this with my compass, which in this case I am, my sharp end is going to be right there on my center of rotation. So that if I move it, my first move is going to be from this guy right here, this first piece. And then I'll just move him, let's just say 90 degrees, which is a quarter turn. I think I went a little more than 90. Anyways. And then you would do that with each piece of your vertex for approximately the same distance. So, in hopes that I did that properly, and I'm sure I messed it up somewhere, I'm just checking it, guys. You don't have to do this. Just checking to see if I screwed it up at all, and I did a little bit. Okay, so this is my new picture, and it's still not beautiful, so don't hate on me for it. Okay, it has rotated across this center. So all of this has transformed to this. And I know this picture is really hard to do. I tell you, I struggle with rotations. They're a lot easier to identify than they are to draw. So I'll give you that. Okay? Your drawings may not be awesome, but it's easy to identify a rotation. Okay? Take a look at the picture of the one in your book, and you'll see what I mean. We're going to go to the next example. It's a connection problem. So I'm gonna go through these, but mainly we're just going to try to fly through these without drawing a whole bunch of notes. Is kind of my point. Okay, so perform a rotation. The first one, it says the image placed on. Imagine placing your finger on one vertex C. So you should be on this next page. Okay, this picture right there is at the top of your page, top right. Okay, so that's what you should be looking at. As I read this, try to do what it says. Zoom in on that drawing. Don't go cray on it. Make it about half of your page and move it far right. That way you can kind of follow along as I say what to do. Imagine placing your finger on vertex C. So go ahead and place your finger on vertex C. And use another finger to turn the rest of the triangle. So don't literally do that. You will zoom in. Your second finger. So if I'm placing one on C, just go like that and imagine turning it. That is a rotation about using C as your center of rotation. Okay? So if I was going to use that as a pinwheel and I went like that and I flicked it, it would spin around that piece. Okay? So that's basically what it's asking you to do. And then you'll redraw it and label your vertexes. So on this one, if it was A, B, C, then this would be A prime, this would be B prime, and this would be C prime. Okay? It's mainly just labeling here. Okay, so rotation was the first part of that. It says imagine pushing the figure, so grabbing it from here and sliding it over. This, again, is not going to be a beautiful drawing, but there it is. If I grabbed it and pushed it over, it is now A, B, C, but now it's double prime. Okay, so this first piece was a rotation, bam. Then this was a translation. And then lastly, if I wanted to reflect it, I draw a line of reflection and go ahead and reflect it. Should look exact opposite of what was there. So these are triple because we've done three things to it now. Okay? So I rotated it, I translated it, and then I reflected it. All with one kind of example. Okay, any questions about either of those? We all kind of know them, I imagine, from like 5th and 6th grade. Okay, just a reminder on how to do it. Then we would want to look at these images, compare them, see how they're similar, see how they're different. So, is there, okay, don't go about my drawing, okay? If I copy these perfectly, we're going to go about it as if I copied them perfectly, okay? Are there any differences in these figures? Not literal, but if I would have done them perfectly. No, there wouldn't be, right? Because all it did was move. It moved, it reflected. They're going to be the exact same, so there's no difference in shape or size. So therefore, it is a rigid motion. So the shape and size of this figure never changes in a rotation, a translation, or a reflection. Now, are they different? Yes, because they've now been changed from one side to the other. If you've ever seen anybody take a picture on a phone and then like of somebody driving, and then they can flip that entire picture around, they'll make it look like the person that, if you're in America, right, you're on the driver's side of the car. But if you flip it, then it would make it look like you were in a European car because you would be on the right-hand side. We're left-hand drive cars. In Europe, they're right-hand drive cars. So if you flip the image, it looks like you're in a right-hand drive car. I've seen a lot of people do that on Instagram or something like that. You can flip your pictures, and it makes it look completely different than it is. All right. Next page. Go from 7 to 8. I don't want to waste a lot of y'all's time with plotting points. I just want to know that you know how to plot points. So I'm going to give you a few examples. Go ahead and draw a coordinate plane, so an X and Y axis, on your paper. Say what? At least 10.
Top and bottom, or
Like that, sir. There's 10 on top and bottom, left and right. And you can sort of build it as we're plotting these too. Won't kill you. My little stamper's losing it. Alright. Remember that the origin, I'm going to list out a few points. We're just going to go A, B, C, D, E. A, B, C, D, and E. Okay, so A is going to be at the point 0, 0. So we need to go ahead and label that point. It's right here in the center of everything, and it's A. It's our origin. Next, we're going to do B. It's going to be at 1, 5. So I'm going to count over 1. This is the x-axis, so remember the x-axis is right here. So I'm going to count over 1, and I'm going to go up 5. 1, 2, 3, 4, 5 on the y-axis. So B is located right there. X, y. It's always x, y. Okay, so this is quadrant 1. I'm going to call this Q1. In other words, both of your units there inside of your coordinate is going to be positive. Okay, they kind of look like funky emojis. Over here on the left top, it's going to be quadrant 2. Over here, they're going to be negative and positive. Okay, in quadrant 4, or sorry, 3, jeez, I'm going to learn to count one day, guys. Quadrant 3, it is going to be negative, right? Negative, negative. Is anybody else seeing the funny emoji faces yet? Last one is Q4. It's going to be positive, negative. Okay, we should already know all of this, but we gotta be reminded at times. Okay, and then obviously the x and y axis is your other ones. All right, so we're going to do C now. It's going to be a negative 3, 4. I'm going to go 1, 2, 3 in the negative direction, just meaning left, and up 1, 2, 3, 4. Put a dot, label it. There you go. That just means left 3, up 4. Next one is going to be a negative 8, comma, negative 2. So I'm going to go left 8, 1, 2, 3, 4, 5, 6, 7, 8, and down 2, 1, 2. That would be D. And on E, we're going to have 7, comma, negative 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. There's my dot. There's my E. Reading better. Any questions, comments, or concerns about plotting points? Okay. When dealing with points that are already plotted on a plane for you, they'll tell you make a transformation 3 units to the left. So if I'm making a transformation 3 units to the left, I'm only moving my x coordinate because my x goes left and right. Okay? So if I'm transforming it 3 units to the left, I'll just count over 1, 2, 3 units. Simple as nothing. Okay? Simple as that. Does anybody still need this? Okay. For a translation. I'm just going to do an example of each one. I'm going to use 1 comma 4 as my original every time. Okay, so if I'm going to go 3 left, then all I'm doing is taking away 3. Left is less, so it's 1 minus 3 comma 4 minus 3. Then I get my answer. If I moved it there, it's going to be negative 2 comma 1. Okay, left is less, left is less. Okay, therefore right you would be adding. Okay, so if you're going let's say 2 right, then you're going to be adding. Oh shoot, why did I do that? Go back up here, guys. Left is less, but it's only to the x coordinate. I don't know why I went ahead and wrote it on the y coordinate too. So sorry. When dealing with left or right, you will never change your y coordinate. It will stay the same. So if I go 2 right, I'm just adding to it. So 2 right will look like 1 plus 2 comma whatever 4. Okay, and then your final answer will be 3 comma 4. Okay, so left and right are fairly obvious. You just subtract and add to your x. So left and right only deals with x. Only deal with x values. Now, if it says, again I'm using 1 and 4 as my original, if it says 2 up, then I'm adding 2. So I'm adding 2 to my y's because my y's deal with up and down. So 1 comma 4 plus 2, and the answer will be 1 comma 6 in the end. Okay. If I'm going down, so let's say 3 down, I'm going to have to subtract from my y's. So it'll be 1 comma 4 minus 3, which will give us an answer of 1 comma 1. Okay. So up and down deal with y values only. Questions about it? Anybody need more time? Next one's going to be a reflection. So we're going to do looking at reflections. Okay. If I'm reflecting oh, this one's tough to explain. I'll just do y-axis and x-axis. So if I'm reflecting over my y-axis, okay, the y-axis being this one right here in the middle, okay, if I reflect over the y-axis, I want you to look at the coordinates of b. b is at 1 comma 5. If I reflect it over, it's going to be at negative 1 comma 5. Okay, so whatever it was original, so if my original was 1 comma 5, if it's reflected over the y-axis, it will become negative 1 comma 5 because its height didn't change, but its location along the x-axis did. Okay, so if I go back up here and I wanted to do the image b prime, then all I did was move it from one side to the other of my y-axis. Same distance apart. And it's going to be just like that. If I'm reflecting it across my x-axis, okay, and again I'm going to look at I'll look at c this time, which was at negative 3 comma 4. If I'm reflecting it across the x-axis, I'm looking right here. It is 1, 2, 3, 4 away. So I'm going to go 1, 2, 3, 4 away, and my c prime will be located at still negative 3. But it's also going to be a negative 4 now. So it does not change the beginning, but it does change the end. Okay? So there's little side notes on these. Whatever you start with, so let's, for example, this one was positive comma positive. It's going to end up being opposite comma the same. On this one, if you start out with whatever you start out with, it's going to end up being, whoops, you're going to end up with the same, comma, the opposite. Okay, so that's all it's changing. So here, the x changes, and this one, the y changes. There's one more, but I don't think we get into those yet, so I'm just going to hold off on it. Let me double check, but I'm pretty sure. Yeah, that's right. Okay, so anybody need more time with this one? Okay, cool. Okay, go ahead and flip the page. You should see some kind of crazy looking shape here. We're going to try to follow this image to pre-image to the next thing. Okay, so first of all, which one's the original figure? Top left, top right, bottom right? Which quadrant? Top left, right? We know that because it's just the letters, correct? What happened to it between the first one and its image? It was rotated, right? Now, was the rotation from the origin? Was it from a vertex? Where was the rotation coming from? I heard somebody say the point of origin, and then I heard somebody say the y-axis. It would be the origin, yes. You can't use the entire line of the y-axis. You could use a point along it, but not the whole thing. Okay, so yes, it is a rotation, I agree. Going from the first image to the second image, which is this one here, what happened? It's a reflection across what axis? X-axis, right? And what about from here to here? Just move. It's a translation, right? Okay, so I feel confident that y'all guys are good there. So next page. Come on. Okay. Example A says identify the transformations that could be applied to figure A and to figure B. So first of all, looking at figure A and figure B, I'm going to blow it up again just a little bit. Looking at them, we need to analyze them. Do they have the same shape? Yes, they're both. They're both rectangles, yes. Do they have the same dimensions? Yes. So, can I perform any of the three that we've already gone over? Yes, because there's no change in shape or size, right? So to identify what transformations can be performed from this to that or from that to this, any of them, right? So we analyze that they are the same shape and size, therefore we can perform a translation, a reflection, and a, did I say rotation already? Rotation. Okay? So they are pretty much the same. Now, if I was looking directly at this picture and I said, what happened from A to B, what would you tell me? You would say a translation because you could just have moved it, right? Or it could be a reflection. Where is its axis at, right? Right about there. So we could say, what if it was a rotation? What could it be a rotation? How could it be a rotation? Where would its origin or its rotation, or center of rotation be? Well, there's no x and y axis here, so you can't tell me that. Where would it be? It would have to be right here, right? Whoa, that's a bad way to do that. It'd have to be dead center with this guy right there, because it could go 180 degrees, and then, boom, there it is. So, has anybody got questions about it? Okay, so it could have been performed any of those three things, and you wouldn't be wrong on any of them, really. So, it can be moved along any of those rotations, translation, or reflection. Go ahead and go to the next page. There's an image here that you need to be able to see, and we're going to ask a few questions based on it. Okay, the question is, even though without its A prime, B prime thing, are these images the same shape and size? Basically, was there a transformation done to them? Are they the same shape or size? Same dimensions, what happened to them? It's reflected, right? Right about there. So it's reflected approximately along that axis. If it's reflected across that axis, then you should be able to see exact same things happening on both sides on the image. So, does anybody have a problem seeing that reflection? Okay, I didn't figure. Okay, so if it told you identify the pieces that were congruent in here in this figure, you would say segment CD is congruent to what? JH, because we're looking at it as if it were a reflection, right? Its corresponding part is JH. Okay, therefore JK would be congruent to BC or CB. I don't care how you say it, it doesn't matter. Okay.